In the first part, I will show you how to use multiple regression to investigate the impact of relationship equity on company performance. Relationship equity including customers' trust, customers' satisfaction, and customer attitude, and company performance in the marketing context, including customer loyalty and customer word of mouth. And both independent variables and dependent variables are continuous variables. Now let's start with our R script. We need to load several required packages, including tidyverse, psych, and ggplot2, right? Let's run the codes. As I mentioned in the previous videos, when you check the b-values, usually the b-value will be expressed in a scientific notation, and it might be brilliant to remove this scientific notation and just see decimal places of p-value, so it's easier for interpretation. Let's run it. And very important, we need to open the data file, right? So let's run the code read CSV and choose the data set. Right. So let's check the column names of the data set. So we have 9 columns: ID, gender, age, vanity, trust, satisfaction, word of mouth, loyalty, gratitude. Now let's check some basic statistics of our data. All right, if you look at these summaries, what do you know about trust, satisfaction, word of mouth, loyalty, and gratitude? These variables are measured on Likert scale from 1 to 7, right? 1 to 7. Now, let's go further and check more detailed descriptive statistics of these variables. All right. So if you look at these continuous variables, you also see the mean, the number of observations, the range. But there are two things I would like you to focus this time. That is the skewness and kurtosis. So the skewness quantify how much a distribution leans to the left or right relative to a normal distribution. So right here we have almost all negative skewness, and negative skewness or left skewed. It means the tail is longer on the left side and most data values are concentrated on the right. And another index called kurtosis. And kurtosis measure whether the data have heavy tails with a lot of outlier or light tails compared to a typical normal distribution. In this case, we have all the kurtosis index smaller than 3. So it means that the distribution of these variables have light tails with fewer extreme outlier. Right. And also based on the summary, we know that we have the variable penalty. And these variables are measured as a categorical variable with 0 means customer will not be charged for the late checkout fee. And 1 means customer will pay the penalty fee. And in the current form, this variable is numeric, and we need to convert this variable to factor or to categorical for further analysis later on. All right, so right here, we would like to convert the penalty variable to factor. What do you think we should fill here? So we already used the function as the factor many times. Basically, we just call the column name. And the column name is penalty, right? Okay. So we can type the data frame that we store the data, which is df, right? And with $sign and choose penalty. Right, and let's run the code. Excellent. So right here you see the penalty variable has been converted into 0 and 1, two levels. All right, now before we run multiple regressions, we would like to check the relationship visually. All right, and how to do that? We can use the scatter plot. The scatter plot is one way we can see the relationship between two continuous variables. If we use the base R scatter plot code plot right here, we can see the scatter plot of all continuous variable, in particular those column 5 to 9, right? 5 to 9, right? Now we can zoom in and we can check the scatter plots we have right now potentially show relationship between two continuous variable. For instance, right here, you will see the relationship between trust and satisfaction. They have a potential linear correlated with each other. In the previous scatter plot, when we use the base R, you can see it's a little bit messy. It's a lot, right? So how about we try a general function and we apply that function for every single relationship between two continuous variables. So right here, we are writing a function to create a scatter plot with ggplot2. All right, so please bear with me. So in this line, basically, we are trying to define the function that we want, and this function needs three inputs: the x variable, the y variable, and the data, right? This line will map the value of x variable to x-axis, the y variable to the y-axis. That's it. And this line will add the data point based on the coordinates of x and y. And this line will help us to avoid the points overlapping, like this one, right? Good. The next code will help us to create a potential linear relationship lines to represent the potential relationship between two variables. And the last code basically just add the title for the plot. Right. Don't forget to run the code. Good. Now, you already have the general function to create the scatter plot already. And we save that function in an object called scatterplot, right? Now, we just use that function and just add specific input, particular, what is x variable, what is y variable, and what data we need. In particular, right here, we would like to create a scatter plot for the relationship between trust and loyalty. So, what is x and what is y? If you look at our research framework right here on the screen right now, you will see trust is X variable and Y is loyalty. So we just add trust as X variable and loyalty as Y variable, right? And let's run it. Good. So right here you see we have much better scatter plot to show the relationship between trust and loyalty, right? But not only creating the scatter plot, you need to understand what does it mean. So basically, you see the positive correlation between these two continuous variables, right? So if customer trust the company more, they probably stay longer with the company, right? We have very dense area right here in the top right corner of the plot. It shows that the majority of customers have both high trust and high loyalty, right? How about these special case? So they are outlier, right? So they are very interesting to be investigated. Why those customer they have very low trust, but they stay very long with the company, and vice versa for this customer. That could be an interesting question for you to investigate. Right. So definitely you can apply the same mechanism for the other scatter plot between sufficient loyalty, between sufficient word of mouth, between gratitude and word of mouth. Right. And it's time for us to run the multiple regression analysis, right? All right, so remember, in order to specify the formula for linear model, you use dependent variable tilde sign and all the independent variables. In particular, right here, we would like to examine how trust, satisfaction, and gratitude affect the dependent variable loyalty. All right, we will run the linear model and save the result in red loyalty. So right here, we specify loyalty as dependent variable, trust, the first independent variable, satisfaction as second dependent variable, and gratitude as the last independent variable, and the data is df, right? Good. Now we can run the code. All right, excellent. So we have the result for multiple regressions right here. Of course, you can check the B values so you can see all the independent variables are significant. All right, but let's look at some other index as well. So residuals. So the residual represents the difference between the actual and predicted values of dependent variable loyalty. So you can see the residuals here are very small and center around zero, which is a good sign that the model is fitting well. And you also have the coefficients, right? Each coefficient represents a change in loyalty for a 1 unit increase in the predictor variables, holding other variable constant. All right. So for instance, for a 1 unit increased in satisfaction variable, holding other variable constant, the change in loyalty will be 0.58. All right. And again, all predictors are statistically significant at b smaller than 0.01, meaning the impact are real, right? And another index you can look at is the multiple R square. So the R square right here is 91%. It means the variation is planned in loyalty by three independent variable: trust, satisfaction, and gratitude is good. This is high value, meaning we have a strong model. Overall, the model is highly predictive, with satisfaction being the strongest driver of loyalty, followed by gratitude and trust. Right? Great. So once you practice, try yourself with the second multiple regression to check the relationship between trust, satisfaction, gratitude on the word map. All right, in the second part, I will show you how to check the effect of marketing strategy on both relationship equity and company performance. In particular, we will check what is the effect of the penalty fee on trust, satisfaction, gratitude, loyalty, and word of mouth. And penalty here is the grouping or categorical independent variable, and all 5 dependent variables are continuous. And today, I will use Anova. Great. So based on the model we just see, if we drive the code for every single relationship between penalty on one specific dependent variable, we will write very long code for Anova, as well as we also need to check the mean difference between different groups of the grouping variable. So instead of doing that, we can write general function to compute the mean of different groups and to perform ANOVA, and then use these 2 general functions to apply for a single relationship, right? Let's do it. All right, so right here, we are going to write general function to compute the means and standard deviation for different groups. All right, again, the first line, basically we define the function that we want. The function we want needs the input of dependent variable, of the grouping variables, and the data. And then based on the data, we will group by the data by the grouping variables, right? And then we tell R to summarize how many observations we have in each group. We compute the mean of dependent variables. For each group, we compute the standard deviation of the dependent variable for each group, right? And we also have the general function to perform ANOVA, all right? So again, in the previous week, we have conducted a lot of ANOVA tests and t-tests, and feel free to check the previous videos on ANOVA tests and especially how to interpret the ANOVA result, right? Good. All right, so don't forget to run the general function. And after that, everything easy, right? We already have the general function on computing the mean on ANOVA test. Now we just use these 2 general functions to check the relationship that we want. Now let's start with this one. We want to check the effect of penalty on loyalty. Okay, if you look at the research model, so penalty is the grouping variable and loyalty is the continuous variable. And based on how we define the function of compute the mean, we see in the first place, we need dependent variable, which is loyalty. And in the second place, we need the grouping variable, which is penalty, right? Right, good. Now, please look at this result. How do you understand it? We have 2 groups of penalty, 0 and 1. 0 mean customer will not be charged for the late fee, right? And 1, yes, customer will be charged for the late fee. All right, so we have equal size for each group, right? 138 and 139, almost equal. And the mean value for group 0 is 6.28. The mean value for group 1 is 4.17. So obviously, the customer without the penalty will stay longer or more loyal to the company, right? So right here, based on this result, we just know the mean difference. But we need to do the second step, which is ANOVA, to check if this difference is significant or not, right? And we already have a general function right here, which is ANOVA test. Now we just add the input for the function, which is what is dependent variable, what is independent variable, and what is the data. That's it. And exactly the same in the first place, we need loyalty, which is the dependent variable. And in the second place, we need penalty. Excellent. And let's run the code. Good. So the result tells us that, yes, the difference between 2 penalty group 0 and 1 is significant as 0.001. And please, again, it's very important to understand the results in the marketing context. All right, and I think you are more capable to replicate the analysis for the other relationships in the research model.